Hello, everyone. Welcome back to Calculus 1000. Say hi to him. Just talking. Today we will continue working on the examples that to cover more examples of related rates. Remember that yesterday we were talking about how to basically start working on these problems, and let me find the chalk, and the solving related rate problems. It had two parts. One is modeling, which is nothing but translate, at least in the problems in this level, means translate the word or the scenario into mathematical format, equations, variables, and information that are expressed in those terms. Then the other part was solve the model, which was just, okay, now, once you're done with the modeling, you can ignore the wording completely. This is about equation given, relates some variables, and you're supposed to find some rate of change based on that equation. Yes? And for that, remember that we did some work, some examples, specifically without involving any of the word problems. For the modeling part, well, you should find your way of doing it. But I outline few steps that can help you to develop the habits or basically the pattern of how to start these problems. In the case of easy problems, those steps will come without any pain. But having that pattern in your mind will help you specifically when the problems get more complicated. And the steps that we had was identify quantities involved, assign them variables, find their relations or write their relation in terms or in form of equations. Find their relations in the form of equations. The last part was easier, the one that we did. You have equation and you find the relation. Find the relation between the rate of changes the key point in all these ones are that we are assuming our variables are all functions of a third variable, usually time, yes? So find the rate of changes with respect to the variable, the third variable, usually t. We did some examples. I want to do small examples now to get a bit more on these ones and try to cover more and more complicated cases. The first one that I want to do is this nice example So we'll take a bit of time to write down the example. A 5 meter long, a 5 ladder. So I have a ladder of 5 meter, is leaning against a wall, a tall wall. The bottom of the ladder starts. So I have a ladder like this, leaning toward the wall. The bottom starts sliding away from the wall. Starts sliding away from the wall. It has more information with constant speed or at constant speed. .6 meter per second. I wish I had a ladder here to show you. But this is like what is happening. I have a ladder leaning there, and then the lower part slides away. As a result of that, the top of ladder will start sliding down, yes? So the question is that at what speed the top of the ladder falls down or slides down when it is 3 meters above the ground. At what speed the top of this ladder will slide down? I should bring a ladder for these days to the class. So this is the ladder, lower parts slides away. As a result, the top will slide down. Now we are trying to see if this is sliding away by that speed, 0.6 meter per second, at what speed the top would slide down for this one, okay? So I will give first 1 minute. 1 minute, and I'm not asking you to solve the problem. I want you discuss with your friend. You're talking, you're drawing, you're trying to point out the important things of where should we start implementing steps like this. And specifically, try to discuss which part, am I done with modeling? Is this done? Do I have the equations? Or should I move to the next part now? Okay? 1 minute, you're not trying to solve, you are trying to identify things first, and then we go from there. Yes, please. With the wall, the assumption is that the wall is vertical. The ladder cannot be, it's going down, yes? It's starting vertical, but then goes down, yes? Okay, so these are the type of questions that you should talk to your friend about. You're trying to discuss with your friend what are the key points specifically to implement these steps. Go ahead, 1 minute starts now, then I will give you some time to try to write down some stuff. 1 minute, go ahead. I need to hear some chatting. Chat. 10 more seconds. Okay, I think it's now time to start writing things on the notebook or tablet. And again, the steps by themselves are not important. What is important is that you're trying to develop this skill of, okay, I see this problem. What kind of things I should look for? Quantities that vary. Let me pick them, all of them, and write them down. Assign them variables. Let's find their relationship. When you're trying to find the relationship or find the equation, draw a picture. That's very important. Because that way you can basically say, okay, oh, this is my x, this is my y, and so on. Okay? I'll give you 90 seconds now. You're trying to now work with your friend or alone and trying to start the modeling part of this problem. Go ahead, 90 seconds starts now.
What's the start?
Actually, just erase it, try again. Really? Still.
Technically, you can.
Okay. So let's start with this. What we know is that 5 meter and it's starting sliding down, okay, whatever you like. What are the quantities? What are the quantities that are involved in this scenario, in this story? Yeah? I'm listening. Yes, yes.
The distance from the top of the ladder to the ground.
Okay, so there is one distance of top of the ladder from the ground. Can you tell us how did you see this could be one of the important things?
Because we're assuming that the top of the ladder, like the distance from the top ladder to ground, starts at 5, and then it's going to slide back.
Slide that. Or a cheating point here is that it is asked that how fast. The quantities, there will be so many quantities, but those are specifically varying, those are changing, those should be in your list. And this, in this specific case, yes, because the question is at what speed this changes, and that is one. The other one is the distance of the bottom from the wall this time. So distance of the bottom from the wall. Now, how about the length of the ladder? It's a quantity, isn't it? It's a quantity in our problem. Should I assign a variable for that? No. Why not?
It's a constant value.
It is changing. That's very important. Well, I mean, I can assign variable, but I can say that the rate of change of that variable is 0, or it is constant. Since it's constant, I won't bother assigning any variable. So now, variables that I will assign, this one I will assign x, this one I will call y. I need those ones to start writing my equations, completing my model, yes? I haven't started basically offering the model yet. But now that I have equations, I want to find a relation on an equation that relates x and y. What would be, or how can I derive the relation between x and y in this specific case? Yes, please.
Well, you can use Pythagorean theorem.
Pythagorean theorem, and that tells us everything, yes? So this is x squared, y squared added equals to 5 squared, or I can write just 25, yes? Okay, I have the equation, but yesterday when we were talking about this, I'm asking you not only get that equation, but also try to write all the given information in terms of the variables. For example, here we know that x is increasing by the rate of, so dx dt, the rate of change of x with respect to time is 0.6 meter per second. And we are asked to find what is dy dt, or something related to this, how fast it moves down, yes, of this problem. But on different stages, this speed will change. And here we are interested specifically in dy dt when the distance of the top from the ground is 3 meters. If you do that, that will give you another confirmation that you have set up your variables properly. So all the information you have to be able to translate and write it in terms of those variables. Now, I completely ignore the wordings. I'm dealing with this model here. At this point, if you have done everything complete and right, then you will see that I don't care now what is x, what is y. There is an equation that relates x and y, and some information is given, and we are looking for rate of change of one of these variables with respect to time based on that equation. And for that, in other words, solve your model, we are trying to get d dt of the left-hand side equals to d dt of the right-hand side. Oh, did you bring those things to see? That's so cool. She has one of these interesting things she watches like that. I need that. Okay, so then I will start differentiating both sides.
Why?
One important thing at this stage we have to remember, both x and y, all of variables, are function of a third variable, in this case time. So we are seeing this not as differentiate with respect to x. It's not 2x, it is 2x dx dt, because I have to implement chain rule there. Plus 2 dy dt y, and derivative of constant. The length was constant, the right-hand side is 0. Well, then I can go ahead and try to plug in all the values given there, yes? So I know that y is 3, so 2 times dx dt is 0.6 meter per second. Do I need to write the units all the time? No, really, in math, doesn't matter really, but I'm using it as another hinting point that at the end, if my units come out correct, it's just another way to confirm that, oh, I'm I'm walking through the right walk, or it seems at least, unit-wise. I have y. What should I put for x in this case? What should I put for x? Yes, please.
This is 4 in this case.
How did you get that for?
Plug in the value like 3 as y, then you know that, yeah, and then solve the equation.
This is the equation that relates x and y without any other stuff. If I know y, then I should be able to find what is x. So here, x squared plus 9 is equal to 25. I mean, 3 squared. Let me write it that way so that you can see. And then you do the work, and that gives you x is either plus 4 or minus 4. Here we are working with distance, so that would be 4 meter. When y is 3 meter, the top is 3 meter from the ground, the bottom is going to be 4 meter from the wall. So then this is 4 meter plus 2 times dy dt is what we are looking for. And what is y? Y is 3 meter. Now I have to do that work. I'll do it here. So this is good. This is 1.2 times that, 4.8, yes. And then I take it to the other side. That's negative. So dy dt is going to be negative 4.8 what? 4.8 meters squared over second divided by 6 meter. And that is negative 0.8. And see, this meter cancels with one of these, meter per second. Well, at least unit makes sense because the distance was meter. Now we are finding the rate of change. That is what we are looking for. What does this negative mean here? Yes, please. The value of y as time passes gets smaller and smaller. And if you look a bit more carefully, the question is not asking what is dy dt. It says at what speed the top goes down. So in other words, the problem, the wording of the problem, this down here takes care of that negative sign. So if I want to answer this question correctly, I would say with the speed of 0.8 meter per second, it goes down. Just a wording that's a bit of here because it's already included that's going down, so we are doing that. Any questions, any comments for this one? Would you like to do another example? Would you like to do another example? Yes. Okay, let's do an eye clicker question. Can anyone have a look at it and confirm that it is readable? It is, yeah? Is it good? Okay, I'll try to write it on the board, but you have the problem. I will do it just for the video. while doing it, make sure that you draw some pictures. Identify the variables, find the equations, go through those steps. It's very important to develop that habit of, oh, this works now this way. I will do this step. That will help you with the more complicated problems. Okay, I think now we have it on the video as well. I'll give you another 20 seconds to wrap up what you're doing already, and then I'll write down the solution. See? Okay. Let's see what are the quantities that we are dealing with here. Can anyone help us out here? So, do you see any quantities that I have to assign variable for? Yes, please.
Height of 40.
So, okay, I'll write it as height. Okay, let's deal with that. Height of the kite. Okay, what else? Yes, please.
The length, or how far it is from you.
The horizontal distance. The full writing would be horizontal distance of the kite from the J. What else? Yes, please.
The rope height?
The length of the string, the kite string. So the length of the string. Well, I mean, you can check if you see any other quantities, you have to write it. And sometimes you need to revisit this, come back and maybe add some more. But for now, I can call this one H, this one D, this one S. Yeah. Height, distance, and horizontal distance and string. Okay. I think you should now see that this is D, this is H, this is S. And we are dealing with, again, a right triangle here. And finding the relation between these quantities is, again, Pythagorean theorem, which is h squared plus d squared is equal to s squared. So let's write the other information that is given. Let me hear the other information given there. Yes, please.
Height is 40 meters.
The height is 40 meters. So now we can see something here that it is going to stay fixed. Yes, the problem says that the height is always going to stay the same. That also can be written in terms of the variable. H is constant all the time, means that it doesn't vary. Is it H? Yes. H is constant means that doesn't vary as time goes on. Its rate of change with respect to time is 0. Also, we know that d of distance from the time, oh, I hate now that d. Maybe I should do d. Just a bad choice of letter. That's the distance. It's increasing 10 meter per 10 meter per hour per minute. Okay. And we are interested in finding how the string will change. Yes? But when h is 40 and what is called d is 30 meters. This is another important point. When you can express all the given information in terms of your variables, it means that you have a good set of variables. It's complete, and you can have everything there. Okay. Now, the modeling is done. I have to solve the model. Means what? The problem is, forget what is h, what is d, what is s. I have 3 variables. They're related this way. Now I want to find the relationship between their rate of changes. In other words, I want to see how they vary, how their rate of change are related. So I take derivative of left-hand side, it should be equal to the derivative of the right-hand side. And while I'm deriving it, I have to make sure that, I am taking care of the fact that h, d, s are all variables of t, so I'm applying the chain rule there. Okay? That's the relationship between those different quantities. Now I have to plug in the values. This is 2 times 40 times 0. This is 0. Yes? So if we kill this term, plus 2 times d was 30 meter, and we know that it changes with this speed, or minute. And the right-hand side, what is the string at the moment, at the point that s and d, or h and d is given, 40 and 30? S is not given, but since we have this relationship here, we can use it and find what is s at that specific point. When h is 40 and D is 30, I have h squared, so let me write it over here, h squared 4D squared plus 30 squared is equal to s squared. And then s, you should get 50. So that is where 50 meter comes from. And now I'm interested in finding this guy there. And that gives me what? So the right-hand side, I have 600 meter squared divided by minute, divided by 100 meters. This is ds dt. And that gives me 6 meters per minute. And it, in some sense, makes sense, yes? As it goes 10 this way, the length of the string, it goes smaller than that part, yes? That's in some ways meaning. And okay, I'm closing iClicker now. Please, if you haven't done, do it in 10 seconds. Do it, please, fast. I have another very good question. I'd love to go through this, but is there any question, any comments before I write this other one down? And yes, please. Louder, please.
Did over there? HDT over there.
Oh, this one? The fact that the height stays the same, I can write in terms of the rate of change of height is equal to 0. So in wording, this is replacing the fact that is written there. The height of the kite stays constant. That's what it means. Yeah?
So DS over DT?
This is what we are trying to find. How fast Janet should let the string go. The S is the length of the string. Now the how fast is ds dt. Yes? So we are trying to find what is ds dt with these information given. Yeah? Any other questions? Any other comments? I love this problem. Let's write this one down. We have a tank, a water tank. Has the shape of upside down circular cone. Which has of the height 5 and radius of 4 at the base. If the water is drained from the tank from the bottom of the tank with the rate of 1 cubic meter per hour, find the rate at which the height of the water in the water in the tank. Goes down when it is 4 meters high. Yeah, write it down. My hand is now hurting.
Reach the height of the water. Yes.
Okay. How about I only, because we don't have much time, I only will give you 45 seconds, and I'll ask you to draw the picture and try to at least put the numbers and variables you think will work on the picture. Cone, circular cone, upside down, what is the height, what is the radius, and go from there. So it is a cone upside down. The height is 5 meters. The radius of base is 4. Now, this is the tank itself. The water inside the tank has a similar shape, but we are interested in finding, and we know that this is drained from the bottom of the tank with 1 cubic meter per minute. And we are interested in finding how fast the height goes down. Okay, quickly, what are the variables? What are the quantities that this problem has, or I have to focus on and write down a variable for? The volume of the water in the tank. So volume of not the tank, of the water in the tank. Is it okay I denote it with V? Yeah? What else? What else? Yes, please? The height of the...
Or the height of the water.
The height of the water. Height of the tank stays the same, yes, all the time. But here, what changes is the height of the water. In the tank. Well, let's write H for that. What else? Are we good with these variables? Can we go on and try to find the relation between these two? Yes? I see. So these are, okay, so that's the next information. So we know that dV dt is -1 cubic meter per minute. Was it minute or hour? Hour. I think I made, okay, this is hour. So that is now given. What else? How can I find the relation between V and H? Well, what is volume of a cone with base and height given? Yes?
Volume is equivalent to 1/3 times H.
So the volume of cone, this is important. Actually, it doesn't matter what is the base. You find the area of the base. In this case, the base here is a circle. Yes? So area of the base, so if I call this guy R, look, already it shows I need to fix R as well, it seems, yes? Because that's how I can, oops. That's the area of the base times the height, 1/3 of that. Volume of a cone is 1/3 of the volume of the same height and same base cylinder. So this is the volume of that part, only 1/3 of that we are taking. Okay, this already shows me that I need to know about R as well, yes? So I may need to go back and add R to my variables. But what would be the rate of change of R in that case? Yes, 0? Wait, as the R goes down, this is not this radius. This is the radius of the base of the water, because water will also be of the shape cone, yes? This will change. For example, if it is here, it is smaller than that. Now we have a bit of a problem there. But that problem can be solved if you cut your cone on one side. So this is basically your cone. I'm cutting that. This is the shape of the water here. Now, here I called it H. Here, this one I called it R. What is this number here? 4. How about the height here? 5. Now, let me erase this other piece. I just look at the half of the cut of that thing. So this is 5. And if I have those two triangles, can you cook up some relationship between H and R there? Can anyone tell us what was that word that important, the key word in this case? Or how do you, similar triangles. These two triangles, since they have this, these are right triangle, and this always going to be parallel to that, they're similar, and similar triangles have same ratio of the corresponding edges. In other words, the big edge, vertical edge here, over this, or the other way around, H over 5 is going to be the same thing as R over 4. Why are you doing all these things? Because I want to, my H and R are not independent of each other. Once H changes, R will change as well. And this is how they are related. In other words, I can write H in terms of, or maybe I should have done the other way around. I wanted to write R in terms of H. Yeah? Now, let's revisit this knowing that R is equal to 4H over 5. In other words, V is going to be 1/3 of pi 4H over 5 squared times H. Or, equivalently, I can say this is 16 over 25, 16 pi over 25 pi H cubed. Once you are there, then you have everything. So now you are trying to find dH dt when H is equal to 4. And you know that dv dt is given there. My model is complete. In other words, I now can ignore what are the physical meaning of these variables. I have a function which relates b to h. I have some information, and I want to find how the d dt are related. So dv dt is going to be 16 pi over 20. Oh, why do I have 2 pi's? This is only 1 pi, sorry. Over d h cube dt. And I'll leave this one from here on for you. This is 3 dh dt h squared. Once I have the model, oh, did I miss something there? What did I miss? Where is the third? Where is the third? It's somewhere there. Let me find it for you. Just wait, just wait. It's just like, that's there. Okay, sorry. I remember at some point I said 75, but I did right. Have a great day. I heard that you guys have an exam. Good luck with the exam. And see you all on Monday.
It's not -1.
Yes, it is -1. No, that's dv dt. So volume is that given by that equation. I'm finding d dt of both sides. Yeah? You are.